In this lecture, we'll discuss about Heron's formula. Before coming to that, we'll discuss some plane figures. For example, rectangle, square, rhombus. And when we draw these figures, we can calculate the perimeter and area. For example, for this rectangle, if I want to calculate its perimeter, there is a formula twice L plus B, where L and B length and breadth. But the perimeter is expressed in the unit of length or the dimension. If the dimensions are given in meters, then the perimeter will also be in meters. And if we calculate the area of this figure, area of rectangle is L into B. But we will express the area in the unit centimeter square or meter square like that. So we can find out the perimeter and area of these plane figures. But when we say area of triangle, immediately it comes in our mind half base into height. So for any triangle, if we have to calculate its area, as I said, half base into height, any of the sides of the triangle can be taken as the base. For example, I am taking BC as the base and its length is B units. It means that any dimension can also be expressed as unit, simple word unit. So suppose its base is B units and the height is H units. So the area will be half base into height. But at the same time, if I take a triangle and for this triangle, if I say the base is B and height, this is some height H, then the area of this triangle will not be half base into height. So what is important? Whichever base we are considering, its corresponding height should be given. Height means the altitude. Altitude means a perpendicular dropped from the vertex to the opposite side. So it is not always necessary that the altitude what we are drawing, it is inside the triangle. In some cases, it can fall inside. In other cases, like obtuse angle triangle, it can fall outside also. But the most important thing is we have to see the base and the corresponding height. In this case, this base is given, but the corresponding height is not given. So what is important? I said corresponding height. So in this case, if I want to find out the area, I must know this perpendicular or I should know this base. So for example, if I say this perpendicular is L and this side is A. So the area of this triangle PQR, it is expressed as area of triangle PQR would be half into B into L, not H. Why? Because this L is the corresponding height for this base B. Similarly, the same triangle, its area can also be written as half into this base A and this height, corresponding height H. So this is A into H. So now what we have learnt, the area of triangle is half into base into corresponding height. So since it's a triangle, 3 sides, so 3 altitudes means 3 heights will be there. So if you know a particular base means a side of the triangle, its corresponding height is important to know, then only we can calculate the area. And as I said, that in some cases, for example, if I take a right angle triangle, this I took an acute angle triangle, so height I had drawn. Now suppose if I take a right angle triangle, in this right angle triangle, the sides except the hypotenuse, the other two sides will act as base and height. If I am taking this as the base, this side will become the height of the triangle. So directly also I can write half into base into, and suppose this is h, so like this. It means you don't have to draw a particular perpendicular, but if this AC is as the base, then we must know this perpendicular dropped on this particular side. So I can also write the area of this triangle as half into AC into BS, because for this AC the corresponding height is BS, but for base BC the corresponding height is AB. So this is the case for right angle triangle. And very interesting thing, the third case, if I take an obtuse angle triangle, for example, any one angle is more than 90 degrees. So in that case, if I am taking this BC as the base, so the height of this triangle will be the altitude dropped from this vertex on this BC. But if you will drop a perpendicular or height of this triangle by taking BC as the base, that height will not fall on BC. So sometimes the height of the triangle or the altitude, it falls outside the triangle. It means it will fall on the produced side. So we can produce this CB till here and this. AD is the perpendicular on produced this base CB. So in this case, the area will be half, BC is the base and AD or H is the height. So all three cases we have discussed: acute angle triangle, right angle triangle, obtuse angle triangle, and we had seen how to find the area by taking half base into height. Suppose we are taking an equilateral triangle. In that case, if we take, for example, the unit or the dimensions, length of this or the side is 10 units or 10 centimeters. So in an equilateral triangle, all the sides are equal and we want to find out its area. Height is not given, but still we can calculate. We can drop or we can draw a perpendicular or height and we can calculate its length, because there is a property of equilateral triangle: when we draw an altitude or perpendicular, it bisects the opposite side. So here this AD will bisect this side. It means BD will be equal to DC, that is 5. So we can calculate this AD with the help of Pythagoras theorem. So in this case, the height of this triangle will be, that is AD, under root of, in this triangle we will see under root of 10 square minus 5 square. So that will be under root of 10 square minus 5 square, that will be 100 minus 25, means under root of 75. Under root of 75 can be expressed as 25 into 3 and under root of 25 is 5. So that will be 5 root 3. And once you know the base and the height, that is 5 root 3, we can calculate its area. So its area will be half into base into height. Base is 10 and height we have calculated. So half into base into height will give us 10 into 5 root 3. This will be 25 root 3. This is the way what we have done. We have calculated the height, but there is a direct formula. That is, if you want to know the altitude, which actually is the height of an equilateral triangle, the formula is root 3 by 2 into side. Let's see. Root 3 by 2 into side. Side is how much? 10. So this is 5 root 3. What you have done with the formula and what you have calculated with the Pythagoras theorem, it is same. So this is the formula. If you learn it, it's okay. Otherwise, you can calculate the height of the equilateral triangle. Similarly, the area of equilateral triangle can also be found by direct formula. That formula is root 3 by 4 into side square. So area of an equilateral triangle is root 3 by 4 into side square. So here side is 10. So that would be root 3 by 4 into 100, and ultimately it is 25 root 3. So just check it out. The area by taking base and height, that also is 25 root 3, or direct if you are using this formula, then to it is coming 25 root 3. This we have seen that when we know the base and the height, we can calculate the area. But just think about a situation in which two sides are equal. Let they be 5 centimeters and the unequal side is 8. So here the height is not given, but we can calculate it. Since the height in this case will be the perpendicular drop from this vertex to the opposite side, and according to the property of isosceles triangle, it will bisect the opposite side. So this AD, if it is bisecting BC, it means BD is equal to 4 centimeters. So we can calculate AD with the help of Pythagoras theorem. In this right angle triangle ABD, AD will be equal to under root of 5 square minus 4 square. So that is 25 minus 16. So it is 3. So the area will be half into base into height. That would be 12 centimeter square. So what we have seen, any triangle, whether it is an acute angle triangle, right angle triangle, obtuse angle triangle, equilateral or isosceles triangle, what we have seen, once we know the base and the corresponding height, then we can calculate its area. Now think of a situation when all three sides of a triangle are unequal. It is a scalene triangle in which how to find the height will be the problem. Now let's see. If I say a triangle is given with all three sides unequal, it means there is no clue how to find out the height. For example, 8, 11 and 13 centimeters are the sides of the triangle. When there is no clue to find out the height of the triangle, how to calculate the area of this triangle? Then comes the Heron's formula. So Heron's formula is based whenever we know the sides, only sides, and we don't know the height. But actually, one way is there to calculate the height, but that is based on the geometrical part. Means from this, if we draw a perpendicular, means from this point A, if we drop a perpendicular, and if we measure this perpendicular in centimeters, then we can find out the area, but we will not go to that part. Rather than that, we will see when three sides of a triangle are given, how to calculate the area of this triangle. So now we will see what is Heron's formula. So in a triangle ABC, normally we denote the sides of the triangle by small letters in front of capital A. If we are taking BC is A units and AC is B units and AB is C units. Then S is the semi-perimeter, means perimeter upon 2. So S is equal to A plus B plus C upon 2, and the area of the triangle, which we represent by this symbol, is equal to under root of S into S minus A into S minus B into S minus C. It means that when we know all three sides of a triangle, by applying this formula, we can calculate the area of a triangle. We will discuss one example. In that, we will see how to substitute the values of S, A, B and C to know the area of triangle. First example, if a triangle is given with the sides 8, 11 and 13 centimeters, then find out the area of triangle. So very first thing, we will calculate its semi-perimeter. That would be 8 plus 11 plus 13 upon 2. So S is equal to 60. Clear? Now we will apply the formula. Area of triangle is equal to S is 16. So 16 into 16 minus 8, 16 minus 11 and 16 minus 13. This would be 16 into 16 minus 8 is 8, 16 minus 11 is 5 and this is 3. When we get the numbers inside the radical sign, one thing we have to remember, we will not multiply this all and increase our calculation. Rather than that, we will factorize it further and then we will bring out the numbers which can be outside the radical sign. So under root of 16 is 4 and 8 also we will factorize as 4 into 2. So we will rewrite it as 16 into 4 into 2 into 5 into 3. These are three prime factors and these two will come out of the radical sign as 4 into 2 and inside the radical sign it will be 10 into 3, 30. So the area of triangle ABC whose sides are given 8, 11 and 13 will be 8 root 30 centimeter square by using the Heron's formula. So this formula is used when we know all three sides and we don't know the height. We can use the formula and we can calculate the area of any triangle. Sometimes the sides of a triangle are not given directly. Rather than that, the sides ratio is given. Then how can we find out the area of triangle? But in case the ratio is given, the perimeter or semi-perimeter will also be given. So we will take one example. In this example, it is given the ratio of the sides is 3:5:7 and the perimeter is 300 meters. Then we have to find out the area of this triangle. When the ratio is given, one possibility is maybe the sides are 3, 5 and 7. Other possibilities are also there. For example, the sides are 30, 50 or 70. Or maybe the sides are 6, 10 or 14. So what are we observing here? With this ratio, there is a constant quantity which has to be multiplied with each number to get these sides. So that number we don't know or that constant we don't know. So we will assume it. So suppose for any x, the sides are 3x, 5x and 7x. This x can be any quantity. So by this assumption, A as 3x, B as 5x and C as 7x With the help of this perimeter, we will find out the sides first. And once we know the sides, then we will apply the formula. So here we have to write for some x. For some x, let a be 3x, b be 5x and 7 be 7x. So we will take the perimeter 300 meters so that a plus b plus c, because perimeter is sum of the sides of the triangle, is equal to 300 meters. So this will be 15x is equal to 300. So x is equal to 20. Once we know the value of x, that we will put it over here, substitute it, and then we will get the sides. So the sides will be a is 3x, so that is 3 into 20 is 60 meters. Then b is 5x, that is 5 into 20, that is 100 meters. And c will be 7x, that is 7 into 20, 140 meters. So once we know the sides, now we can apply the formula and we can calculate the area. And we require the semi-perimeter. So once we know the perimeter directly by dividing it with 2, we can find the semi-perimeter. So here in this case, semi-perimeter will be 300 upon 2. That is 150 meters. Now we'll apply the formula. Area of triangle is equal to S into S minus A into S minus B into S minus C, where S is 150, first side is 60, second side is 100, and the third side is 140. So we will open the brackets. 150 into 150 minus 60 is 90, 150 minus 100 is 50, and this is 10. Here we will not multiply all the numbers. As I said earlier also, rather than that we will factorize them further. But you can see 4 zeros. 4 zeros means 10,000. So that we will separate. And what is left out? 15, 9, 5. Or directly we can write 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. When these 4 zeros are inside the radical sign, this is the square of 100. That will come out. From this 9, 3 will come out. This 15 we will break as 5 into 3. Why? Because that 1, 5 and 1, 5 here. That will come out from the radical sign. So further we will write it as under root of 5 into 3 into 9 into 5 into 10,000. Now we will bring out the numbers which can come out of the radical sign. They are 10,000 will give us 100. Then this 1, 5 and this 1, 5 is 5 into 5, 25, which is square root will be 5, as well as under root of 9 will be 3. So that will also come out. What is left out inside the radical sign is this 3. So that 3 will remain inside the radical sign. So the area of a triangle, this is the area. The area of the triangle is 1500 root 3 square meters, because the perimeter was given in meters. So when the ratio is given, we can find out the area of the triangle where the perimeter is 300, and by finding the sides we can calculate the area of the triangle. Now we will discuss what are the applications of Heron's formula. Sometimes the triangle will not be given. The combination of triangles can be given, or a figure will be given in which we can draw the triangles. For example, if a rhombus is given and one of its diagonal is given and the side is given. For example, ABCD is a rhombus and its side is A and the diagonal is D. So we will apply the properties of that specific figure which is given to us. This is a rhombus and we know the sides of rhombus are equal. So all the sides will be A. And if one of the diagonals is given, we can find out the area of one triangle and multiply it by 2. This is the second property. That these two triangles will be equal in area. So one triangle we can find out and we'll multiply it. And how can we find out the area of this triangle? By taking the sides A and D. Similarly, if any general quadrilateral is given and all its sides are known, for example, all the sides of this quadrilateral are known to us and one of the diagonals is also known, for example, then we have to apply the Heron's formula twice. For this triangle, the sides will be A, B and L. For this triangle, the sides will be D, L and C. So separately, we will apply the Heron's formula for this triangle and for this triangle and we will add it up. Sometimes it can be given in the form of a design. For example, a tile is given which has two triangles. So here also, if it is given these two are identical, then by finding out the area of this triangle means these three sides will be given to you. We will find out the area of this and we will multiply it by 2. So in different figures, we can use the Heron's formula, means not directly the triangle, but the combination of triangles can also be given. So in that case, we will see how many triangles are there. We will apply the Heron's formula and we can calculate the area of that given figure.